Today I'm going to give another webinar titled Applied Wireless Solutions, where I want to explain a little bit more about our products in a different approach than just lining up product in one list. So today I will start with I just go through the index. This presentation is an update on our product line, and unlike the standard product introduction, in this presentation we like to give you an horizontal projection on how EnGenius products can be deployed. And at this moment we can divide EnGenius products in three major categories. The first one is solution-based solutions, where we have our Neutron Series, the distributed network management solution. And the second category is standalone. We also call that our Electron Series, where we have indoor and outdoor access points. And last but not least, we have a SOHO line, a very small series of SOHO products. But in this presentation, we would not highlight it for today. So, we will start with the Neutron Series. This is our solution-based product. And this is actually the current product line that we are focusing on. And actually, the first coming slides will be is actually repeating of what I did a few presentations before, where I totally explain the features and functions about the Neutron Series, but I like to repeat it now because it will give you a whole line of what can we do with EnGenius products. Well, the Neutron Series is, as we call, a distributed network management solution. It's an AP-managed, license-free wireless infrastructure. Main specification in this infrastructure is that we provide is that we have a management switch that manages the network on AP level. The access points are managed by the management switch. In just a few sentences, we can summarize the function of this solution as follows. So we have one all-in-one switch, which is a layer 2 switch with PoE and with management function. And we have indoor and outdoor access points. And I actually added one more word in my presentation for today, and it is our Wallplate indoor access point, which is going to be a new product. I will have a slide later in this presentation. And well, in general, the access points have to be wired, connected to the PoE switch. Not only for the management, but since it's also PoE switch, also the power function will be coming from the PoE switch. You can scale our deployment in combination with up to 20 or 50 managed access points and EGS PoE switches. When you use our EGS PoE switches, these switches will be recognized by the Neutron management switches, and you can monitor port status as well. So as mentioned, an EWS switch can manage up to 20 or 50 access points, depending on the model. And still the deployment is upscalable to manage multi-EWS cells through our new EasyMaster software, which is currently under development. Actually, 2 weeks ago and 3 weeks ago, we had our first pre-launch of our EasyMaster software in a few countries through some customers. And this is some new upcoming. I have also some advanced information later on in this presentation. So, where's my mouse? In this slide, I would like to emphasize the target market. This solution, our EWS Neutron solution, is designed for small deployments where you want to cater 20 to 1,000 clients through up to 50 access points. The solution can be a part of a bigger setup in combination with radius servers, traffic logging servers, and internet gateways. The solution is positioned in places where easy management of access points is required. It is not a management system on client level, but it can be a part of it. So the key point for our Neutron solution is easy installation, easy configuration, scalability, low investment, and last but not least, no licenses. Well, the function of our EWS solution in the total network. The EWS Series is a managed access point solution where an EWS switch manages the function of the access points in a central place. So the main function in our EWS systems are auto discovery, provisioning, wireless configuration, monitoring, and controlling of the access points. So as you see here in this slide, I make a drawing here where I position our EWS switches here. EWS switch one in one deployment where we can have a few PoE switches. Additionally, to roll out the whole network, because you have to power up all the access points with PoE and connect it to the EWS for the management function. Next slide. In this slide, this is a list of the full features, but I have other webinars dedicated to this. Just to remind you, in the whole list of webinars, there are archived webinars where you can still watch the previous recording of the webinars. Let's go back to this slide. Like I said, additional network services are not integrated in the management switch because we believe that certain functions should be done by dedicated devices. Functions and services like fast roaming, authentication, billing, captive portal, logging, and UTM functions should be done by these. Whether or not combined, it should be done by the external devices, special devices that are dedicated to do these kind of functions. However, in our EWS solution, fast roaming on KNR protocol is already built in to still facilitate a fast roaming protocol. Not the original fast roaming where you need an authentication server, but there is a simplified fast roaming protocol, and that one is already built in our EWS solution. So, talking about applied wireless solutions, I would like to go to our first basic setup. Well, I recommend the EWS solution to be used starting if you have a deployment where you need 4 access points to start with. If you have a smaller deployment, there is not really a need to manage multiple access points because there are just a few. And so I would recommend to start with 4 access points. And later on, I will explain a little bit about the EasyMaster, and even without an EWS switch, you can still manage access points on a certain level without the EWS switch. Well, in this slide, I show you the components to start with. If you want to have a deployment of 4 access points. So we have 1 management switch, and we have 4 access points. These all have to be wired to the switch for PoE and for the management the management of the access points. And in this case, you are able to cater up to 80 simultaneous users. I have a star in my notes here. I used the number 80 at this moment because I like to publish and to talk with and to calculate with numbers that are realistic, workable. I mean to say that if I want to calculate a deployment in a wireless environment, there are so many environmental factors that cannot guarantee your wireless throughput and your wireless connection. So I like to calculate always 20-25 users to be connected simultaneously to one access point if I want to calculate. So in this case, I have 4 access points, so I can cater up to 80 clients, 80 simultaneous users in my deployment here. Of course, in the real situation, there would be much higher capacity to connect to our access points, but in many times there are so many environmental factors that will decrease the performance of the wireless in general, that I like to use workable, realistic numbers. Starting from this basic setup with 1 switch and 4 access points, we can cater up to 80 users, and we can actually easily extend this deployment into a more into an environment to cater more than these 80 users where we are talking about. For instance, first of all, the switch can handle up to 20 access points. So even this PoE switch only have the capability to directly connect 8 access points. Well, actually, we can start to connect 4 extra access points here to fully utilize the PoE function. And if we want to connect more access points, we can still use the management capability of this EWS switch and add up a non-management switch like our EGS switches, just to provide the power and the connection capability to more access points, up to 20 access points managed in total by the first EWS switch. The next slide is actually a more advanced setup. So for larger deployments, you can make bigger EWS cells with management up to 50 APs. And actually, if you look at this drawing, I have actually this switch is actually representing 1 EWS switch connected to a second EGS switch, just a normal PoE switch, and a third switch here. It can be connected by fiber because we have our SFP ports, SFP slots in our switches. Just add up another SFP module into our switches to make fiber connections between them for more throughput. And in this case, you can already have a bigger solution, even with multi buildings on your site. And these deployments are typically used in buildings, multi-building sites like schools, offices, factory sites. And at the end, you can facilitate up to 1,000 clients. Let me move my own picture here a little bit. So I have here 1 EWS switch, which can manage up to 50 access points, and in this case, maybe 2 EGS switches for the next building. And in total, we can manage up to 50 access points. And if I talk about this number of 20 access points, 20 clients per access points, we can do 20 times 50 and then we come to 1,000 users to cater from this system. Okay, let's put this back. I want to go to the next slide. Next slide. Yes. Okay. Like I said, we have our first pre-launch of our EasyMaster software. I just like to mention it very shortly. What is our EasyMaster? Well, for real multi-site management, EnGenius is developing the EasyMaster distributed management solution software. It is a Linux-based software that needs to run on a local server or cloud instance. And the main features are as follows. So it's a multi-site management. You have to, from the software, from the server, you can manage multiple EWS setups. And the management should be through the cloud or the internet, and it integrates multi EWS setups. A few features here is management redundancy. You can manage multiple EWS cells, but even if your internet drops out, our EWS switch can take over the management, do the backup there, and after the connection is re-established, then it will resync the information and all the logging data. There is no limitation on the quantity of access points that you can manage. The only thing is that, of course, you're also depending on your hardware and your throughput capabilities of your network and your server, and only there is the bottleneck. Very important here is that EasyMaster will be provided for free, and there will be no license fee on top of it to manage all the access points and all the networks in your deployment. The software currently is under development, and it's is expected to be launched in the end of Q3, maybe Q4, for the official release of the software. So yeah, we hope to have it soon and to see it really working in real life. The last slide that I have for our EWS series is, like I mentioned in the first slide, we have a new subcategory in our EWS product line. So we have our switches, of course, we have outdoor access points, we have normal indoor access points, which are the ceiling mounts. But the third type of access point that we are going to have very soon is the Wallplate wireless management access point, and it's a very unique product where we combine an access point with a little advanced but very compact switch, and these access points are specially designed for hotel room deployments or maybe classroom deployments, where you want to have managed access point capability to be the connection point for all the network associated devices. I have one here. It's actually quite small. So and the back side looks like this. The connection points are here as shown on the picture. The Wallplate access points are mounted to the wall where the network connection comes out, so your normal wall socket. So therefore you have a special bracket like this, which you have to screw over your the hole of your wall outlet, and then the cable has to go through this, and then you connect it to the back side of let's see if we can make it closer, of the back side. Actually, there's also a picture here of the back side of the access point, and let me see. So it has to be connected to screwed on the wall, and you have to connect to the back side. So there are RJ45 connectors here, and there is also a 110 punch block connector to fit more easy installation. So you can make it cheaper, you can make it flatter, you can make it smaller. There are a few different ways to connect it for more flexible installations. So So there is this LAN connection on the back side, and there is also a pass-through. The pass-through, for instance, if you would like to make a very clean installation in your wall, you can just let the pass-through go. The blue one from here will be directly go to this one. So if you look at our schematic here, for instance, if you have a traditional telephone system, you can connect the one end to the telephone system on the back side, and your telephone line coming out from here. So there's even one PoE output here. So for instance, if you want to use a VoIP telephone that needs to be powered by PoE, you can also connect it through the access point powered by the PoE of the access point itself. We are going to have two different models, a single band model and a dual band model. There will be some price difference depending on the project. You can choose for a more cost-efficient solution, but you can also go for the full dual band to provide dual band access to all the clients. Let me see, I think I have a question here. Okay, you can post questions, just as a side note, you can post questions in the question box, but I will answer all the questions after the webinar. I will answer the questions personally. Let me put this back. Okay. The outdoor series. EnGenius has many years of experience in outdoor solution and was pioneer and expert in long-range wireless devices. Currently, we apply our experience in our models, but for Europe, we decided a few years ago to fully comply with the local legislation, and our devices follow the European law by special European firmware. So if you look internationally, EnGenius is always published and expressed as the long-range specialist. We are still a long-range specialist, but just to let you know, EnGenius follows the European law for the European products with special firmware. So I just would like to go through following slides and show you a few main deployments, pointing out what EnGenius can do for you, and which models you need and what result you can expect when you use our access points. So I would like to start with the endpoint access point mode, which how I always call this endpoint access point mode. This mode is actually the most basic mode you can have for a wireless deployment, as you have an access point, so you have the basic mode is the access point mode. And if you talk about the endpoint access point mode, in this case the access point is the final point in the deployment, the point that connects your network to the client and to the smartphone or tablet or laptop, etc. So talking about outdoor solutions, this mode can be used to cater wireless access in campus squares, hotel swimming pool, restaurant terrace. Well, and typically most deployments require omnidirectional antenna. And things that are important if you are looking at an outdoor endpoint access point deployment, there are a few parameters that are important. So here are the most important listed out. First of all is the definition of which frequency band you want to use. You can use only single band 2.4 gigahertz, but you can also use dual band. Currently, dual band is growing rapidly, and even 11AC is growing very fast. So that's also the second step. First, you first have to decide. I want to go only for 2.4, or I want to do dual band. But yeah, maybe I also want to do 11AC. So currently there is a big growth in those devices, iPhone and all the new high-end smartphones. Currently, they're all supporting 11AC, and currently the new laptops that are sold, they're also already equipped with 11AC. So I think 11AC is also very growing, and we have to consider, if we want to deploy a network, do we want to be ready for 11AC? Okay, of course, in the Western Europe, this is the trend at this moment. But there could be countries like Russia, they don't even accept 11AC yet. But of course, yeah, whatever is valid for your country, you have to follow. So first, the selection of bands, 11AC, if you want to add it. So the third thing that you want to consider is the coverage and density of the network. Based on the coverage and density, you can select the model and quantity of the access points. As an omnidirectional endpoint access point, EnGenius can offer up to 1 kilometer radius coverage. So, and with our access points, we are able to cater 60 to 70 users per radio, depending on which model that you are using. We have multiple SSIDs, and so you can even divide your same wireless network in separate groups, and we have many other advanced features. If you look at the different models that we have, I make an illustration here on different models. The left AP is our ENS series access point. It's the most cost-efficient access point with external omnidirectional antennas, and it has various modes. It comes with 2.4 or 5 GHz radio. So it's a single radio solution for the entry level, and it's suitable for many deployments. So in this comparison pointing out the access point mode, it's the cheapest one that we have, and it has a range up to 200-300 meters, depending on the frequency. Like if you use the 2.4 gigahertz, maybe 200 meters. If you use the 500 gigahertz, you can maybe go up to 300 meters. Yeah, because the output power of 5 gigahertz can be higher, so you can have more power on your access point. So the second access point, this one, is the ENS Enterprise Series, the ENS 1200 1750. This one actually has also an omnidirectional antenna, but this antenna is a special design built inside the housing of the access point. So don't let your imagination fool you here that it has no external antenna. But actually, it has no external antenna, but the internal antenna are also omnidirectional. And these we call it a patch antenna, and these have a simulated omnidirectional antenna pattern. It would be able to do 500 meter radius, but of course we are always depending on the environmental factors here that can have a disturbance on the wireless signal. In the last, in the right, I have to point in this slide, in this picture here, we have our ENH Enterprise model. We have a few models here. We have the ENH 1750, we have the 900, 710. All the models, they share the same platform with high capacity mainboard to cater high throughput and many current users. We have, most of them are dual radio, but we have one model is the 220 is single radio, and the 900 and the 1750 come with 11 AC support, and you can choose between 2T 2R and 3T 3R stream models for the 1750. Models with higher streams and 11 EC will of course achieve higher throughput on further distance. And I just point out a slide here just to compare which models. We have a low-end model here, the ENS SMB, the ENS Enterprise, and the ENH Enterprise, and you see the difference in the coverage, what a access point can do. Okay, so up till now we have talked about access points with external antenna to have an omnidirectional coverage. But as a variation of this coverage, we can also do another thing. Even if we want to use endpoint access point to give access, wireless access to clients, instead of giving an omnidirectional deployment with one antenna or two antennas, three antennas in one spectrum, we can also do something else, and we call it sectorizing. And even if you use a directional antenna, you can still have an omnidirectional deployment if you combine a few access points together. And in this way, because normally a directional antenna will have further distance but on a smaller angle, and if in this way you can have more sectorized and further coverage using separate access points for just a part of the sector of your deployment. So for instance, the ENS 202, which has a directional antenna, has an angle of 90 degrees, so it can cover a 90-degree sector. In this case, you can cover a square starting from a corner, for instance. And for certain deployments, this could be a very suitable solution. Yeah, for instance, if you have just a terrace and you want to cover it, you can choose to use an omnidirectional device, which have a 360 degree, but you can also put the access point in the corner and beam it up 90 degrees from one corner over your square. What you also can do, like I said, you can combine it. So if I'm talking now about the ENS 202 with the 90-degree angle, if I use two in this, like in this drawing, you can cover 180 degrees, 2 times 90 degrees in the deployment here. The second classic deployment is outdoor. For outdoor is the point-to-point mode, and most access points with directional antenna, mostly access points with directional antenna are used for pure point-to-point deployments. One access point should be in access point mode, and the other access point should be in client bridge mode. And you can choose models to use the 2.4 gigahertz or 5 gigahertz band in your deployment. Kind of like you're making if you use a point-to-point mode, you're kind of replacing your cable with some wireless thing to have two cables to have 2 points connected to each other. So this is normally what the point-to-point connection is doing. So EnGenius product line includes different models for point-to-point models to have. We have different models for point-to-point or point-to-multipoint deployments. So on both ends of the deployment, you have cable connections, and for instance, to bridge two buildings of networks together. So if you want to connect further wirelessly, you have to add another indoor access point. Well, in this classic point-to-point deployment, devices are set in AP and CB mode, like I said. And if you want to set up a transparent bridge, then you have to use WS bridge mode. And my next webinar is going to explain a little bit deeper into different WS modes and what happens, and I will explain you further in the next webinar. But just in this webinar, I just want to point out, if you want to have a transparent bridge, then you can use WS bridge mode. And in this case, the access points are wirelessly connected to each other by MAC address, and it functions as a pure cable-to-cable connection without losing VLAN tags and etc. It will just like you don't even see the wireless connection interrupting in your connection. So point to point, the classic thing here shown out in an illustration. So based on antenna angle, you can reach wider or further distance, and it's very common that our customers will bridge up a wireless connection up to 10 kilometers with our access points. Of course, that would be in an ideal situation with line of sight, 100% how to say, fine-tuning and aiming at each other. 10 kilometers is doable, but I always say, okay, for normal deployments, typically 500 meters to 1 kilometer is normal. I make a overview here in my next slide. This is comparing our end station, our I have to point here, our end station, our ENS series, ENH series, and our ENS series. I have this drawing in blue because I like to indicate that I'm now talking about 2.4 gigahertz models, because there is some kind of typical difference in the 2.4 models. 2.4 models in general have a little bigger angle, and in Europe, it's the 5 gigahertz is allowed to do higher power. So the numbers are different, and my 5 gigahertz, normally I use the color red to indicate that something is 5 gigahertz. So, but in this slide, end station with a smaller angle, 65 degree, ENH 70 degrees, ENS 80 degrees, smaller angle, smaller angle, but higher gain in antenna, and the ENS have the lowest gain in antenna. So you see the difference in capable to make capable distances. So for the end station up to 2 kilometer, ENH 1 kilometer, ENS 2 500 meter. In the 2.4 series, if I go to the next slide, you can see that the angles are different here, especially on the end station. We have 30 degrees here, we have 60 degrees here for the ENH, and 70 degrees for the ENS. And so the distance can be way further, both for two reasons. Angle is smaller, and second is that in 5 gigahertz, you can, like I mentioned here, you can go up to 30 dB EIRP, which is allowed for the outdoor solutions. Of course, in all general, all the numbers are, I give are workable numbers. Like I said, there are also people making bridges even with ENH or ENS for up to 10 kilometer in the most ideal circumstances. So these numbers are just, like I said, the workable numbers. So, but in real, the capacity of our access point is mostly much higher. So another a variation on point-to-point is point-to-multipoint. So within the range of an angle of the access point, you can connect multiple client bridges instead of one. So in this case, you can set up point-to-multipoint deployment using directional access point. Normally, you have an omnidirectional, and that has 360 degrees, and you can, within the 360 degrees, you can connect all the client bridges. But even if you use a directional, within this range, the angle of the access point, you can still put the client bridges there. The good thing is when you use directional access point have more further coverage. So depending on your situation, you can if you use 2 directional access points, you can reach a further distance. So I also have a picture of a point to multipoint with an omnidirectional. So in this case, you know, the point in this slide, the reach of this kind of deployment comparing to this deployment is that this one is the distance is shorter, but of course the angle is much wider. In this case, it's 360 degrees. Okay, so how in real life do we do this? And I have a small case study here. I had one customer here, and he said, "Well, I need to have a wireless setup here for a few cameras that I have on a parking lot." And the cameras need to be connected wired, and they will be installed in a light. I'd say it in a light thing. There is power there, so only for the data they have to have a wireless connection. So in this following slide, I will quickly show you here how this happened, and because of the distance, we already quickly decided to go for a 5 GHz solution, and in this case, we selected the ENH 500. And because of this specification, so we have 5 GHz because we have less interference. We can use higher power, like I mentioned before, and 60-degree angle is very important to also consider this. And initially, we had 3 points where we had cameras, and we want to from one point we had to reach out to all these 3 points. And let me see how my next slide looks like. So it's probably like this, but then this illustration only have 2 points, but in real it was 3 points. And we were trying to find out the best solution. And initially we wanted to make 3 separate bridges using in one point 3 access points to sectorize it, like I explained in the previous slides. At the end, we just did this. We had 1 access point with the ENH. We have 60 degrees of coverage angle, and we had all 3 client bridges within the range of the 60 degrees. And actually, in the real deployment, the angle was even more than 60 degrees, but the coverage was way good enough to cater for all these client bridges, all the 3. So at the end, we were possible to reach the 60 degrees, and actually it was a little bit more. And we had 6 cameras, 3 in a pole, 2 connected to 1 access point, and they were able to do 1080p at 30 frames per second, and they all came out into 1 access point. And the real throughput that we were managed to have in the first central access point was 50 to 60 Mbps with multicast enabled. In case if you talk about IP cameras, you always have to calculate how much throughput do I need at the point where I go into my wired network. Because many times, if you have more cameras, the data throughput will stack up. And at the end, if you have many cameras, you will your access point that is connected to your network will be the bottleneck of your network. And if that access point, if the capacity is not high enough, then your throughput is, you don't have enough capacity to get all the camera data. So that's why in the beginning we also wanted to consider to use multiple access points to have more throughput in total, but at the end, one access point was enough. So the customer saved the cost of 2 access points in this case study. Okay, a total different thing that I want to explain at this moment is WISP. In some European countries, there are WISP providers, so wireless ISPs. In some countries, there are totally no wireless ISPs, so depending on your country and your region. And in this case, the ISP broadcasts a wireless internet signal. Now, clients need to have wireless device to connect this to this WISP, and the device that will pick up this wireless internet signal we call a CPE. Well, for the WISP solutions, both our ENS series and EnStation series are equipped with client bridge mode and client bridge and client router modes. So in this illustration, you see we have, like I said, the WISP is broadcasting a wireless internet signal, and we use our ENS, or it can be EnStation as well, in either client bridge mode or in client router mode to make a data connection for our household. Well, depending on if you want to use the client bridge mode or client router mode, you need another additional router or access point to make the wireless connection into your home. Okay, another applied wireless solution that I want to talk about is base station access point. And in this picture, I have pointed out a few ENH 1750s, which we actually call the general name for our 1750 900 is actually base station AP, because it's the most common for these devices to be used in this deployment. And in this case, the ENH 1750 EXT is set into WS mode on 5 GHz. So you have a transparent connection to link the devices together, and this part we call backhauling. And the end clients, the final clients, are connected to the 2.4 GHz, and that we put in a normal access point mode. So in general, it's very common to use dual radio enterprise access point like our ENH series to set up 5 GHz as backhaul, and we use the 2.4 GHz as endpoint AP. So of course, the ENH series with the dual radios, the radio functions you can set up separately, so many other combinations and deployments are possible. But for this presentation, just to point out our base station access point example here. Okay, so next I would like to go through our indoor series. How can we use our indoor series in our in wireless deployments? EnGenius, we have 3 indoor series, which is the EAP series, which is ceiling mount access points. We have the ECB series, and we have our EGS series. Our EGS series are our PoE switches, and so we have the ceiling mount access points and the multifunction access points. For indoor, we have actually, and we are quite confident and proud to say that we have the best wireless component in any deployment. We're using the Wi-Fi standard, and we have proven reliability. Once customers use EnGenius, they want to keep our products. And the EnGenius indoor series are typically used in office or hospitality environments, starting from a single access point solution up to a multiple AP solution, and you can use WDS. And like I explained in the beginning of the presentation, we have Now also our EWS series, which use the same hardware structure, but now it's even managed with an EWS management switch, or even the EasyMaster. But still, we have our indoor series, and all our indoor series can be part of a bigger deployment if you want to combine it with radius server or something. In office and hospitality deployments, the most popular is the EAP ceiling mount access points. Because of the design, you can just screw it on the ceiling, and it's very low profile. It's very in the background. You can even turn off the LEDs that doesn't blink and it doesn't draw any attention to it. And we even got in 2012 we had a Red Dot Design Award for our EAP model access points. For industrial series, for industrial purposes, we have our ECB series. Well, if you like antennas screwed on the wall or on the ceiling, of course you can always use our ECB series. But actually, our ECB series are even more. The modes are more. More different modes inside, and the antennas are detachable, so you can even drill a hole in your wall and put the ECB inside and connect antenna on the other side of the wall outside. So all these kind of special features are more for the ECB series. Well, and as a third line, the EGS series, we have full gigabit PoE switches to complement our indoor access points, and also our EWS series can be the EGS series can also be a component of our management solution, the Neutron Series, the EWS Neutron Series. One small case study that I'd like to point out in this presentation is our ECB 300 or ECB 350 home improvement solution. In a few territories in Europe, the ISP provides their own modem router, and actually, like I said in the previous slide, our ECB is more for industrial or for office, more heavy use with special deployment. But what we see and where we actually sell our ECB the best in the biggest quantity is that it's used by the end user to improve the coverages in large houses. They will just directly connect the ECB to their existing modem router with or without disabling the wireless of the original router, and they will use our ECB to have coverage in the whole house instead of just one room of the house in the original situation if you use the original router. So in this case, in this slide, I just point out that even if we have industrial grade or office grade devices, there are some other deployments where customer find a good solution in our products. The last thing that I want to point out, a small case study, is the WS setup. I always said that, yeah, our access point can be used standalone, and if you want to use a few access points, you can also do it in WS mode. And above that, you can use our EWS management system. But just a quick study about how to deploy WS. Well, in this case, I have a small office where I want to deploy a wireless network, but I only have the capability to have power. So in this case, I have office where I want to make a network without AP wiring. So we choose to set up a base to do a setup based on WS topology, and with WS AP you can connect multiple access points to become one virtual access point. And the access points are bridged to each other by MAC address, and they will all be connected to each other, and at the end you will see one virtual AP. So here schematically, how you see how the network is plotted out. We have placed 5 access points. We linked up 5 of the access points through WS link in WS AP topology, and we actually have 1 access point virtually, and we only have 1 connection wired to the network. In this case, with 5 access points, we made a small deployment to cater the wireless for this office. Yeah, so the result, linked up wireless network, and it will, like I said, 1 virtual AP, and we have network redundancy in case one access point would, for some reason, power drop out or something, then the other access point will still be able to cover the range of it will still maintain the connection between the others, because you have a redundant data connection. When you're using dual band access points like the EAP and the ECB, you would be able to use 5 GHz as backhaul and a 2.4S endpoint access point to connect your clients. You actually have a similar deployment as I showed in our EnGenius Series, which we use. Yeah, the deployment is actually the same topology as an outdoor, but then you use it also for indoor. So in this case, you can split the backhaul and endpoint access points from each other to maintain the network throughput. This is actually the last slide for this webinar. I'm right inside the time. My next webinar is going to explain a little bit more about WS and how to use it, and what are the benefits and the cons about this. So I would like to invite you to 2 weeks later for my next webinar. I will leave the presentation open, the webinar open for a few more minutes. So you can still post some questions, which I will answer after this webinar. So I hope to see you soon again in my list of attendance here. And well, see you next time. And thank you for your attention.